Hi there, welcome to this video. This is 2A and we're going to talk about residuals, regression, and error. So let's go ahead and jump in. We are going to learn to construct an exponential model using regression, and then we'll talk about what residuals and error are. From this lesson, you should be able to create an exponential regression model using a graphing calculator, and also you should be able to use a residual or an error to determine whether a model's prediction is an overestimate or an underestimate, as well as use residuals to determine if a mathematical model is appropriate. If you like using TI Inspire, here are the notes in order to how to create a regression. All the process for regressions are the same, except you just choose which type of regression you want. We're focusing on exponential regressions in this lesson, okay? I do want to go ahead and talk about these vocabulary words too as well, residuals. So this is an important topic in this lesson. A residual is the difference between the actual output values and the predicted output values. And a student once told me this, they use the acronym RAP in order to help remember this, that your residual, remember this, residual is actual minus predicted. You take the actual data and you subtract what you were predicting. Now, if your residual is negative, that means that your predicted value was bigger than your actual data point. And so what that is going to mean is that you had an overestimate. You were overestimating what you had. Okay, so if residual is negative, you get an overestimate because actual minus predicted. Predicted is bigger, you overestimated. When your residual is positive, actual minus predicted is a positive value. That means that your actual, okay, was bigger than predicted. So your prediction was underestimating. Okay, so if residual is positive, you get an underestimate. I don't really store this information in my brain. I think it's tedious. I just remember what a residual is, RAP. Residual is actual minus predicted, and then I take the information and I can determine, okay, is it an over or an underestimate? If the predicted value added to the residual will always equal the actual value. Now, you can go ahead and see a residual plot, and I'll show you this on Desmos, is a graph of the residuals. And a regression model is just a justified appropriate model for a data set of the graph has no discernible pattern. Okay, so if it's appropriate, you're going to get no discernible pattern. I want you to underline this or highlight this or write this down. An appropriate model is appropriate if there's no discernible pattern, meaning my residuals, when you see them, are kind of all over the place. If there is a pattern, then you're having a bad model because the data is telling you there is a pattern, but your model is not fitting that pattern, and it's not appropriate. So remember, pattern bad, no pattern good. Okay, so that's kind of what you need to remember for this lesson. And then lastly, a residual has an opposite or a counterpoint, which we call an error. And again, I don't store error into my brain. Error is the reverse. Error is predicted minus your actual, EPA, the Environmental Protection Agency, the EPA. So an error value is just the opposite of a residual. If error is negative, that means you had an underestimate. If error is positive, you had an overestimate. Again, I just know that error is the opposite of residual. I just store RAP, not the EPA. Okay, so let's go ahead and let's kind of see how this can kind of play out. The table below shows the actual data values, x, y, and the predicted output values by a linear regression model. The residuals and the error values. The graph shows the actual data values as distinct points and the linear regression model as a line. So just to give you an idea of what's going on, here is your actual data. This is our actual data. And I guess they ran, or they had a model, and here's your predicted output values. Here's your model. So we can calculate residuals just by subtracting these. If I take 0.8 and I subtract 1.34, we get negative 0.54. If I want the residual for the x value 2, I take the actual data point and subtract the predicted, positive 0.33. So on and so forth. Okay, so that's how this next column, right, this is your residual. And I know I'm kind of double labeling, but that's how we get these values, right? Actual minus predicted. Now, the error will just be the opposite. It's always going to be the opposite. So if my residual is negative 0.54, then the error will be positive 0.54. Okay? And what do I have? Do I have an overestimate or an underestimate? Well, look at your predicted value. Isn't your predicted value bigger than your actual? That's an overestimate. So if your residual is negative, then you get an overestimate. If it's under, your predicted value is under, you have a positive residual, and so you get an underestimate. Okay? So let's go ahead and let's look at an example. Okay? So here's example number 1. We're given a table of the number of people in thousands who liked a celebrity post H hours after posting. They say create an exponential regression model L of H for the data. So I'm going to go ahead and I'm going to go to Desmos, and Desmos is really easy to create a regression. All you need to do is add a table. Again, click the plus icon, click table, and then you can enter the data. So 0, 2, 4, 6, 8, and our data was 0.5, 1, 1.9, 4.2, and 8.8. So I have my information in, and you can see it graphed over here. And if I want to create a regression, all I do is I click this icon, that little line with the 3 dots up here in this corner, and it says, hey, here's a linear regression. Well, I don't want linear, I want exponential. I want exponential regression. Doop, there we go. Okay, and if you get this option for log mode, always go ahead and turn that on. You want that on. And there we go. So there is our model. Now, this equation is right here, so I can go ahead and write this equation down. So L of H is approximately 0.48555. I always like to use 5 decimal places in things like this, 43124, but I think you might be fine with 3 decimal places for a final answer. There's my regression. And then they say B, use your model in part A to predict the number of likes 11 hours after posting. So they want L of 11. L of 11. And so you can go ahead and you can copy a regression equation. If you click this icon, it will bring down your equation without rounding, which is great. And I'm going to change it from y equals, I'm going to change it to a function. So L of x. And there's my function. Now I can say, hey, Desmos, what's L of 11? And then they give me the answer here. So L of 11 is 25.065297. And it's important to note that this is in thousands. In thousands, according to our prompt here, right? Okay, so there you go. There you go. Now, I do want to point out, too, I'm going to go ahead and kind of get rid of this, how you can go ahead and you can see residuals. So right here is the residuals, and you can click plot, and you'll see the residuals down here. They're given in a different value. So I can change the color. I can make them purple, but zoom in here. Okay, and so look, there's my residuals. Now, hopefully this changes with me. If I change this to a linear function, okay, notice how I have this kind of parabolic curve between my data here, right? So here, 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 here. Isn't there a pattern, right? It almost looks parabolic. So that would be a pattern that's bad. Okay, there's a better model to fit my data to. Okay, here is a practice problem. Please go ahead, pause video, create this regression, and then predict the number of bacteria after 6 days. Okay, hopefully here are the values that you got. B of D is approximately 2.4244 times 4.36941 to the power of x. And again, you get this by entering your data into Desmos, clicking the icon over here and creating an exponential regression. And again, what I did is I copied this equation down, and I changed it, I retitled it from y into a function b based upon x, and I just asked Desmos what's b of 6, and it gave it to me, okay? All right, so that is regression. Here's some practice for calculating residual and error, and is their value an overestimate or an underestimate. Again, what you're going to do here is you're going to subtract these values in order to get a residual. Residual is actual minus predicted. So here I could go ahead and get, what, 0.26. The error will be the opposite, a negative 0.26. And then is this an overestimate or an underestimate? Again, if your residual is positive, that means that your actual was bigger. Okay, so you underestimated. So this is an underestimate. And you can go ahead, just fill in the rest of these, and we'll see what we get. Okay, here are the values. You just subtract actual minus predicted. That would be a negative 0.27. The error would be the opposite, and we overestimated. That's an overestimate because our model is bigger than our actual. And then here's the other values. If you want to go ahead and verify your work, you can pause me or just copy this down. You can pause me, okay? Let's go ahead. Let's look at some questions that will appear possibly on the AP exam. Some practice questions here. All right. For a given regression model, a residual value is 0.63. Which of the following estimates is true? The actual data is 0.63 more than the predicted value, and it's an under or an overestimate, or the actual data is 0.63 less than the predicted value, and the predicted value is, again, an over or an underestimate. Pause me, try this one, and then we'll talk through it. Okay, hopefully you tried this one. This, again, is what I write on my paper whenever I have this type of question. Notice the residual is actual minus predicted, RAP, R-A-P. And if you have a positive 0.63 residual, that means that your actual was 0.63 more. Your actual was more. So I'm going to throw out C and D. And furthermore, my model underestimated, right? Because this was lower than this, underestimate. Answer is A. Did you get A? All right, let's go ahead and check out this next practice one. Again, go ahead and pause me. For a given regression model, a residual is negative 1.2. Which of the following statements is true? Is the actual data 1.2 more than the predicted, or is it 1.2 less than the predicted? And again, is it an over or an underestimate? Pause me. We'll talk through this one. All right, hopefully you got this one. If your regression's negative 1.2, that means that your actual value is less than your predicted because you're getting a negative quantity. So we're going to throw out here A and B, and if this happens, that means your prediction was 1.2 bigger, so you overestimated. The ideal would be 0. If we could perfectly predict and accurately predict, that's the ideal, right? So here we overestimated. Okay. Not last one. Try this example here. So for the regression model, the error value is negative 0.62. Which of the following statements is true? Okay, remember, I told you RAP is my bread and butter. Here I have residual is equal to actual minus predicted. I don't use error. I just know that residual is the opposite. So I put, again, back my residual 0.62. So what's true? Well, we're going to be 0.62 more, and that means that your prediction was an underestimate. Answer A. Answer was A. Did you get it? Hopefully you did. Okay, last type of question here is dealing with regressions, and is it appropriate? Well, we have residual plots, so here's residual plots, and we're looking for patterns. Is there a pattern? If there is, then it's not an appropriate model. So these two, not appropriate. Not appropriate. And then this one is going to be appropriate because I can go ahead and it kind of looks like there's a pattern, but it's not a smooth pattern. Like these ones, definite pattern. Okay, so go ahead, pause me. I want you to try these next two. So pause me, look at this one, we'll talk through. Okay, looking at this one, I don't really see a pattern, so I think that this is appropriate. I would say it's appropriate. So I'm going to throw out B and D. And so I would say it's appropriate because they do not show a pattern. That's the big idea. If your residuals show a pattern, like in this one, then it's not appropriate, okay? So I kind of gave this one away, sorry. Look at this pattern, right? This is not appropriate. This is not appropriate. I'm going to throw out A and C because they show a pattern. It's not appropriate because there's a pattern. All right, in this video, we went ahead and we talked about regression, how to make a exponential regression, and we talked about residuals. Remember, residuals are the difference between your actual data and your predicted data. If your residual is positive, you underestimated. If it's negative, you overestimated. And remember, residual, the opposite of it is an error. Remember, residuals, actual minus predicted, wrap. Okay? Hope you learned something from this video. Give it a thumbs up, like. I'll see you in the next one. Later.